Alkanes are named by joining the ane ending of the word alkane with the Greek root word. In this case, we use the Greek root words like meth to mean 1, eth to mean 2. The figures represent the number of carbon atoms per molecule. Prop to mean 3, but to mean 4 carbon atoms, pent to mean 5, and so on and so forth. Using meth as the root word, we have methane, which is the first alkane. It is important to note that alkanes adopt a tetrahedral geometry. In the tetrahedral geometry, the bonds experience minimum repulsion, and this is essential for the stability of the molecules. We also have propane with 3 carbon atoms. In addition, we have this one, which I want you to guess. You must have guessed butane, but it is not 100% correct. This molecule is also called butane. So how do we distinguish it from the other butane? So the cyclic molecule is called cyclobutane. The other is usually given N-butane. So if you want to be more specific, more precise as a scientist, you need to call it N-butane instead of just butane to avoid ambiguity and barriers in communication. Cyclobutane can also be represented as a square, while N-butane can be represented in the zigzag notation. This is usually important to avoid bulk and spending so much time drawing out the hydrogen atoms and carbon atoms. Let's look at the branched alkanes. How do we name branched alkanes? Here we shall need to use the functional groups. Functional groups are simply groups of atoms that are joined to the main chain. For example, we have the alkyl groups with the general formula CnH2n+1. In other words, an alkyl group is one hydrogen less an alkane. For example, we have the methyl group, which is one hydrogen less methane. We have the ethyl, propyl, and so on. Isopropyl, isobutyl, tert-butyl. Let's try an example. The first step is to count the number of carbon atoms in the molecule. So you identify the longest chain, which is the parent chain, and count the number of carbon atoms in it. In this case, there are 4, so that means this is butane. So we have the functional group, which is the methyl functional group, at position 2, in other words, at carbon 2. As a result, this compound is 2-methylbutane. The 2 points to the position of the methyl group. What if we have another methyl group? So we can count from either the other side. In that case, it is 3,3-dimethylbutane, but we can also count from the opposite end to give us 2,2-dimethylbutane. According to the lowest sum rule, we consider the direction which gives us the lowest sum. As a result, we shall consider 2,2-dimethylbutane as the correct name. Let's change the position of the methyl group. In this case, we form 2,3-dimethylbutane. Always remember to put a dash, call it a hyphen, between a figure and a letter, and commas between figures. Using the zigzag notation, we can also represent this molecule like this. And this is usually for simplicity, also to save time. There are other functional groups such as the halogens like fluoro, chloro, bromo, and iodo. In the last example, let's consider this molecule. We count the number of carbon atoms in the parent chain, which should be the longest chain. There are 7. This means we shall use the root word hept. Next, we identify the functional groups. We have the isopropyl functional group. We also have bromo. Therefore, the name is 6-bromo-3-isopropyl heptane. We also put into consideration the alphabetical order of the functional groups when naming. That's why 6-bromo is written first before isopropyl. So this is how we name alkanes. Let me know what you think down below in the comments. Otherwise, see you in the next.